Today I've been working on this lesson actually, and I didn't realize that I could actually just do it here with my lovely daughter Beatrice videotaping me. But I've been writing this lesson plan today, or lesson map today, and we're just going to begin right now. And so everybody get your notebooks out and a nice fresh page, and go ahead and write yourself a title. Today we're going to be writing a quadratic equation from a parabola, given a parabola. And so that's a little different, right? In the past, we've all known the drill of go ahead, we're given the function, in this case y is equal to x squared minus 6x plus 5. And if I wanted to set up a t-table, it's already done here, but what would I do? I would set up my t-table and then I would what? Yeah, I would pick my x values over here, pick easy ones, correct? I picked 0, 1, 3, and 5 because I know they're easy. And then what would I do? Okay, so I've got some x values over here. Of course, we have y values, but how do we get those y values? That's right, we're going to take our x value and substitute it into our function, calculate our function out, and that's going to give us a number, right? 0 squared minus 6 times 0 plus 5, that equals 5. What is that value? That gives us a value of 5. What is that value? That value is the y value that goes with this x value. And what do we know? We know that that's what? It's a point somewhere over here on our parabola. In this case, it's 0, 5. It would be out there. And of course, we could do that for our other x values, substitute them in, calculate our y values, come on over here and plot those points and sketch out our graph. If we wanted to be a little bit more intelligent about it, we could apply, we could factor our quadratic equation here. We could factor our quadratic equation into two binomials, and then we're going to apply what property are we going to apply? I think I'm moving fast. What property are we going to apply in order to determine the value of x? Well, we're going to apply what? That's right, the 0 property. We know that if these two multiplied together are equal to 0, then we can set each of those binomials equal to 0. And of course, I skipped a step, I'm sorry. But of course, you end up with x equals 5 when y equals 0 out here. And you end up with x equals 1 when y is 0 out there. And then we could go ahead and plot our roots on there, go halfway between, find that x value, find our vertex. And again, we've got the parabola, a little shorter, a little easier, a little cleaner than the t-table over here. Of course, if the parabola was somewhere else, the t-table might be a pain in the neck to try to find where that vertex is. But today, we're doing the opposite, or we're working backwards. And instead of starting with the function and generating the graph, we're going to start with the graph. We're going to be given the parabola on the graph and be expected to come up with the function. In this case, y is equal to x squared minus 6x plus 5. So, we could look at the standard form. We all know it. Oh, I thought I had it written up here. I don't, but I'm writing it now. Ax squared plus bx plus c is equal to 0. And what do we know? What does that get us? We already found out it gets us the roots. So they could give us the two roots in here, right? Let's say they gave us 2 points. Let's say they gave us the parabola. They gave us 2 points. They happened to be the roots. In this case, they were 0, what are they? 0, 5, and this one was 0, 1. Or I'm sorry, 1, 0, and the other one was 5, 0. My bad. Bonus point if you corrected me on that in time. We could give you those roots, but as we know, there are how many parabolas that may go through that root, those two set of roots? There's an infinite number of parabolas that may indeed go through those two roots. In fact, I have this parabola here going through those root number 1 and root number 2 here. I've got the pink parabola going through root number 1 and root number 2. I could have an upside down parabola, right? A negative parabola going through these two roots at x equals 1 and x equals 5. So that doesn't really help us. I could get a third point, plug them into that standard form down here, and get 2 more points, right? And now I have 3 points. These are my 2 roots. Notice I've substituted them in. I've substituted those in. I now have 3 equations when I've substituted the roots as well as that vertex there. I now have 3 equations with 3 unknowns. What are those unknowns? Yeah, go ahead. That's right, A, B, and C. And I've got 3 equations. What could I do to solve this? Anybody? Yeah, that's right. I could solve it as a system of equations. In this case, it's 3 equations with 3 variables. That's a lot of calculations. Do we really want to do that? Okay, do we want to chug through all that just to get to take our 3 points and come back to y equals x squared minus 6x plus 5? I don't think so. I don't want to do that. So, we have during the year, or I should say this past unit, talked about standard form, quadratic equations in standard form. As I just showed you, ax squared plus bx plus c is equal to 0. But as you recall, we've also worked with quadratic equations in vertex form. And I know everybody has, said, hey, why do we have to learn more than one form? What's the point? I know how to do it with standard form, with my roots. Why I can complete the square, that's a whole other story. Why do I have, it's related. Why do I have to do this vertex form? Well, sometimes different forms are a little more powerful than others. And in this case, the vertex form allows us to use just 2 points. And actually a fairly simple algorithm in order to go from our graphed parabola over here. In this case, I got my 2 points there, and come up with an quadratic equation. We could even get it to simplified standard form if we wanted to. So let's just go. Does anybody remember the formula for the general formula for the vertex form of a quadratic equation? Go look in your notes. Yeah, look in your notes, please. Okay, yeah. That's right. Y is equal to A times the quantity, x minus h squared plus k. And who can tell me what h and k are? That's right. H and k are the values of the point, the x and y values at the vertex down here. So let's say now, they give us this vertex. And let's just say that they gave us this point 0, 5 over here. I think that's the one I used. Yeah, 0, 5 over here. They gave us 2 points. Let's see what we can do with that. So one of those points happens to be the vertex, and that's a big clue, that maybe vertex form is going to help us. So what are we going to do? We're going to take our x value and our y value, and we're going to substitute them for h and k in our general form. What do we got to be careful about? Yeah, that's right. We got to really be careful about the sign on this number right here. Because remember, this is a positive 3 over here, but the formula is x minus h, and so it's x minus a positive 3. Right? So don't be fooled, even though that this, after I do the substitution, look, I put my positive 3, my x minus my positive 3 here, plus my positive k here. Of course, positive k happens to be what? Negative 4 at this point, exactly. And so then I'll go ahead and come down here, and that gives me a little more simplified version of it. Don't be fooled by that sign. H is not negative 3. Okay, H is positive 3. It's minus a positive 3. Okay, so let's just go drop from there. Normally I'd write all this out. Let's go ahead and drop from there to our other point. And actually I'm going to bring that back up here just so we can have the, well, it's not going to fit, but I'll come back if I have to, just so we can have the rest of the problem. So right here, we also had our point of 0, 5. So they gave us 2 points. They gave us this vertex, and they gave us the 0, 5 here. Who could tell me what does the 0, 5 represent? Yeah, go ahead. Yeah, that's the y-intercept. Very nice. And so now they've given me just 2 points. Y-intercept, the vertex. Okay, it's already a little bit easier. Oh yeah, here we go. And so we got our other point. We need to use another point in addition to our vertex at 3, negative 4. So again, they gave us also 0, 5. what do you think I'm going to do with it, right? When in doubt, substitute. So I'm going to go ahead and put my 5 in for the y. That's this y. And I'm going to go ahead and I'm going to put my 0 in for the x right here. And I'm going to chug this down. I'm going to simplify it. Of course, 0 take away 3 is -3. And -3 squared is what? -3? I'm sorry, -9? No, it's +9. Thank you. So now I have what? 5 is equal to 9a times 9 minus 4. Oh, let me back up. I'm sorry. What is a? Who can tell me what a is? Does everyone remember the definition of a? Yeah, that's our stretch factor, right? That comes back to, it dropped down there, but it comes back to that parabola being stretched or not so stretched. And so where was I? Oh yeah. So we were here then. We're solving for our stretch factor a. We've got 5 is equal to 9 times a plus 4. What's my step? That's right. I'm going to add 4 to both sides. That gets me 0 here. Of course, that disappears. Now I have 9a is equal to 9. Normally, I'd wait. Who could tell me my next step? That's right. Divide by 9, divide by 9. The 9's cancel. I end up with a is equal to 1. Or really, 1 is equal to a. So what do you think? Am I done? Do I got my equation? No. But I do have all the pieces. I do have all the pieces. So what am I going to do? I'm going to come back here, and I'm going to go ahead, and I've got my +3 in here from my vertex. I've got my -4 over here from my vertex, and now I've got a. And what can I do with a? That's right, I can substitute it in, and that's going to give me, therefore, right? We all know it's therefore. It gives us our function y is equal to 1 times the quantity x minus 3 squared take away 4. Now we've put our equation together, but we don't necessarily want to leave it in that form now, do we? Because we all love our standard form. So where is it? We can take our what? We can take our vertex form. Where'd the 1 go? The 1 disappeared. We don't really need the 1, do we? Stretch factor of 1. 1 times x minus 3, the quantity x minus 3 squared is indeed just x minus 3 squared. And so what am I going to do? I'm going to go ahead and FOIL, put my little crab on there, simplify. I'm going to get now, when I FOIL that, I'm going to get x squared minus 6x plus 9 minus 4. What do I not want to forget? Yeah, I don't want to forget to bring down that minus 4. Don't just leave it up there and expect you'll remember it down here, correct? So we're going to bring down that minus 4. We're going to, normally I do this in red, we're going to what? We're going to collect our like terms. Thank you very much. We've got +9, -4. That gets us to +5, which gets us to our now familiar standard form of y is equal to x squared minus 6x plus 5, where we started before we dropped the board down there. So I want to just thank you very much for participating in my short class today, and I hope to see you soon. All right, can you hit it, B?